let's pick up where we left off. We looked and we saw for test statistic, we're going to be using this formula in 9-1 because we will know sigma. And let's look at this next example. Okay, so we're going to go through the steps. I'm going to number the steps. Of course, numbering the steps is it's not important that, you know, step 1, step 2, step 3, but I'm going to number them so I can just follow this right here. Okay, 1 through 6. Writing step 1, step 2 is really not necessary, but I want to make sure I cover every detail. So in step 1, and if you want to pause this and read through it first. Now in step 1, I'm going to write my hypotheses. And again, you may want to pause and try to do some of these things on your own and then go back to the video. We're assuming, and again, this is always some type of population parameter. It's the mean. And we're assuming that it's 4.5. That's from previous information, 4.5 minutes. And the alternative would be that it is not. That's always an equal. That always has a non-equal or some kind of inequality. Step 2, we need to write down some information. We need our sample size, and we need our level for alpha, which they're going to determine for us, and so it's 0.05. And step 3, we choose our test statistic formula. Well, since we know sigma, we're going to use our z-scores. Step 4, we want to draw our rejection and non-rejection regions. Since we have an alpha of 0.05, alpha over 2 would be 0.025, and we're familiar with those critical values. And let's draw that. So that's 0.95. That's our non-reject here. Alpha over 2, each of these tails, we're doing two-tail test right now. There is such a thing as a one-tail. And the z-scores for here are negative 1.96 and positive 1.96. Now what we're going to do is we're going to calculate that test statistic from the formula that we had on the previous page, and that is z-stat equal to x minus mu over sigma over the square root of n. And from that sample, we had that sample average. So that's 5.1 minus 4.5 over sigma, which was given in the problem as 1.2, over the square root of 36. And when I did the calculation, I got 3. Okay, and then step 6, do we reject H of O? Well, 3 is over here in the rejection region because it's larger than 1.96. So since 3 is greater than that upper critical value, we reject H of O. And as a manager, since the average time is not 4.5, maybe we need to look at decreasing the wait time with some process. Now, the next thing we're going to do is the hypothesis test using the p-value approach. And so we're going to stop right here, and we'll continue that on in the next video.